Hello students. In our previous videos, we learned how to find mean of group data x bar using formula sigma fi xi upon sigma fi. But we know in cases when values of fi's and xi's are large, calculating the product fi-xi is time consuming and hard. So in order to make values smaller, we subtracted our assumed mean a from all xi's and thus found new set of deviated values called as di's. Observe that these values of di have now reduced and shifted towards the left. And so now calculating fi di becomes easy instead of calculating fi xi. Now we can find the mean of this data by using formula x bar is equal to a plus sigma fi di upon sigma di. We know this method is called as assumed mean method. Now in today's video, let us see derivation of this formula. And let us also solve one example to understand this formula. So students, observe this table on your screen from our previous video. And suppose if we want to calculate mean of this new column fi di, can we? Yes students, we can. Just the way we did for our direct method, x bar is equal to sigma fi xi upon sigma fi. But students, as you know, this formula is used for calculating mean of the group data. And here we want to find mean of FIDIs that we calculated. So we use formula d bar is equal to sigma FIDI upon sigma fi instead of the original formula. Recall that we calculated di by subtracting xi's from assumed mean a. So let us substitute this in our formula instead of di and we get sigma fi into bracket xi minus a upon sigma fi. Now students, solve this to get the second equation. Looking at this equation, can you guess what sigma fi xi upon sigma fi is? Obviously yes, it is our x bar, which comes from our formula of direct method. So let us put this x bar in our equation 2 and we get d bar is equal to x bar minus sigma fia upon sigma fi. On solving further, we reduce our equation to d bar is equal to x bar minus a. Therefore, x bar is equal to d bar plus a, or we can write it as x bar is equal to a plus d. Now substitute again the value of d from our original equation 1 and we get x bar is equal to a plus sigma fi di upon sigma fi. Now this is the formula students to calculate mean using assumed mean method. You can see that here we are adding a, the same a which we subtracted to calculate deviation. This compensates for our subtraction and thus mean that we obtain here is mean of the original data and not of the deviations that we found. Students, in this method, the value of mean so obtained does not depend on choice of our assumed mean. That is value of xi that we choose as assumed mean. So, assumed mean can be chosen randomly. So we have derived formula for mean for the assumed mean method. As the name says, in this method, we assumed one of our xi's as mean and then we calculated deviation di by subtracting assumed mean from the other xi's. And by doing so, we observed that our values of xi reduced, and shifted or deviated towards the left. That is, it deviated by A units. And this deviation of numbers was compensated by adding same unit A. Say for example, it is 450 here for this data table. Now calculate FIDI and apply this formula to find mean of this table. Well, we will see this whole method, but in the next video. Yes, in the next video we will solve some problems using this formula.